Today we will be navigating the standalone engine for SimOpti. I recommend watching this tutorial in full screen on your device, as some of the buttons in the standalone engine may be hard to see otherwise. So first, let's run the simulation that we set up in our last tutorial. You can navigate this screen similarly to the canvas in SimOpti by panning using a right click on the mouse and zooming in by holding down the control button and using the scroll wheel appropriately by zooming in and out. So first let's pause this and go over some of the buttons in this navigation bar at the top. First, let's start with some run options. You can resume the model by clicking the Run button at the top left corner, or just to the right of it, there's a drop-down menu for some further run options. First is the simple run option, where the model runs for the duration of the specified time interval on the front page of any logic. Run until runs the model to a designated stopping point, which can either be defined by hours from the beginning of the simulation, or to a designated date and time. So here, the model is set to automatically stop after 20 hours since the beginning of the simulation, which is October 1st, 2019 at 7 a.m. So if we set the constraint to 24 hours, the model will run until October 2nd, 2019, 7 a.m. So as we see here, the model stops at 7 a.m. on October 2nd. If we set the model to run for, we can change the interval of time that we designate to run the model for. So let's test this out by running the model for 1 additional hour, so the model will stop on October 2nd at 8 a.m. And there we go. Now the speed of the simulation can be increased or decreased by 500-fold. So, by resuming the simulation, notice the time, we can slow down the simulation speed by 1/500th, or increase it by 500 times the regular speed. Currently, the model is set to its maximum frame rate refresh interval. But by resuming the model, and decreasing the frame rate, we can visually see the differences. These buttons are additional navigation features where you can reset the positioning of your configuration on the canvas. You can zoom out and in using these magnifying glass icons, or you can select this button to full screen your scenario and return by hitting the escape key. You can also return to the AnyLogic front page by clicking this button here to view experiment, and return to the canvas by viewing the top level agent. The total execution runtime for the simulation is displayed in the bottom right corner. Before moving on to additional features, let's reset the simulation. To do so, return to the front page of AnyLogic. From here, we'll actually increase the speed to ×2, and to reset the simulation, click the Run Last Scenario button. This will take into account all of the changes that you may have made on the SimOpti cloud-based platform. So looking at the canvas, we can view different commodities as different colors moving through the network. The red numbers on the screen indicate the maximum rate or target rate for volumetric flow, and the blue numbers on the screen indicate the actual volumetric rate. Waitlist for route is where the queue appears when there is a backlog in the system of scheduled nominations. To force this to populate, let's first close off our final destinations and speed up the model. So now we have material that's being prevented from reaching the final destination. So let's build up our queue a little more. And now that we actually have a queue of multiple, let's enable our final destinations again and let the model run. The model will automatically be able to work through the queue to send the material to the final destinations and then run as originally scheduled. The waitlist for volume and space functions similarly to the route waitlist, but in the sense where this waitlist is created for insufficient space for incoming material for a node such as a tank, or having insufficient volume available for a minimum export requirement. Next, we move on to these two drop-down lists on the right-hand side, with the left list being a list of agents and the list on the right being a list of objects. The drop-down list of agents are a detailed view of hard assets in the canvas, such as tanks, nodes, inputs, and outputs. The list on the right is a list of objects, which is a detailed view of the configured components in the model, such as nomination plans and commodities. Before moving on, let's reset the simulation. Now you'll notice at the bottom left-hand corner, there's another time slot that indicates the number of hours that have passed since the beginning of the simulation. Now let's take a deeper look into one of the components to look at the details of material flowing in and out of the node. So to enter a node, click on the name of the node. In this case, let's look at tank number 2. So inside tank number 2, we can get a look at the inflow material and the outflow, as well as the overall inventory of that node, if it has that capability. In this tank, we can look at the batches coming inbound to the node, and we can see the details of its composition here, and the name, the density, commodity, and shipper. We can view more details of this information by clicking on the name of the batch in nomination inbound, where that information and more is viewable in a table form. Also, we can see the tank content, which allows different qualities of material to be mixed if two different nominations are being mixed into the same tank. Now, this information up here may have different rates from what you're used to seeing on the canvas. That's because the information displayed here is in meters cubed per second, as opposed to the barrels per hour that you're used to seeing on the canvas. Now let's speed up our simulation so we can see some outflow material. There we go. And now we can see the commodities that are outbound from the node in the same format, where we can look at the qualities of the different composition, so gas, oil, and water, the name of the nomination leaving, its density, commodity, and the shipper. And again, that information is available in table form by clicking on the name. Also, we're able to look at the different batches that are coming in and out of the node. As well as different properties of that tank. In earlier tutorials, we created data exports. We created a data export for quality and throughput, both being exported on a daily basis. We can view those data exports with the click of this button, where we have 51 quality report logs, now at 54, and we did not configure any throughput data exports for a tank. So let's check the quality. And here we can expand the window and can look at the quality report for material passing through this tank. Let's return the canvas, and we can do the same by looking at the destination and looking at the throughput log for final destination 1.